Does Larsen Ice Shelf impact ocean currents? Imagine a giant floating sheet of ice stretching hundreds of miles along the Antarctic coast. That's what the Larsen Ice Shelf looks like. It's a massive part of the Antarctic landscape, and it plays a key role in the region's geography. But does it influence the ocean currents around it? That's what we're here to find out. The Larsen Ice Shelf is made up of thick ice that extends from the continent into the Southern Ocean. It acts as a barrier between the land ice and the water. When the ice shelf is stable, it helps slow down the flow of glaciers feeding into it. This means less fresh water enters the ocean, keeping the water's salinity and temperature more stable nearby. But when parts of the Larsen Ice Shelf collapse or thin, things change. The collapse of sections like Larsen B in 2011 caused a lot of ice debris to break off into the ocean. This debris and the melting ice add fresh water to the surrounding waters. Fresh water is less dense than salty seawater, so it can change how water layers mix and move. This can influence local circulation patterns close to the ice shelf. Warm water masses, like the circumpolar deep water, also affect the ice shelf. These relatively warm waters can reach the base of the ice shelf through deep troughs. When they do, they cause basal melting, which thins the ice. This melting changes the properties of the water underneath, including its temperature and salinity. As a result, the flow of ocean currents in the area can shift because the water's density and temperature are altered. After the ice shelf breaks apart, the ice debris and seasonal sea ice in nearby bays are carried by local currents. These currents are influenced by wind and the movement of water around the continent. When the Larsen Ice Shelf is intact, it acts like a physical barrier, constraining water flow. When it collapses, the water and sea ice can move more freely, changing local circulation patterns. So, in a way, the Larsen Ice Shelf does impact the ocean currents around it. It influences water flow by adding fresh water from melting ice and by acting as a barrier that shapes how water moves in the region. These changes are mostly regional, affecting the nearby coastal waters and the marine environment. They don't control the big global ocean currents, but they are important for understanding how the Antarctic region responds to climate change. In the end, the Larsen Ice Shelf is a vital part of the Antarctic coastal system. Its stability or collapse can change local ocean currents, which in turn affects sea ice, marine life, and how heat and nutrients are transported in the Southern Ocean. These processes are essential for understanding the health of the polar environment and how it might change in the future.